Hello everyone, welcome to this video. This is lecture number 88. Already 87 lecturers covered to solve the supplementary problem of the book Vector Analysis by M.R.Spiegel. You know this book is very important for physics as well also for mathematics and also for IIT JAM examination. That's why you to decide to solve the supplementary problem of this book. In this video, we want to solve the supplementary problem 7.79 to 7.80 of chapter 7 with conscious Curvilinear coordinate system. You know very well about the Curvilinear coordinate system. You already attend the previous lecture. The link of the previous lecture given in the description box. You can check the description box. So let's start with question number 7.79, which says let this and these two coordinate system rectangular and the curvilinear coordinate of a point. Okay, this is two system and these are related to that. If you watch the last video, you can see the similar uh, transformation are given here, right? Is this system orthogonal? First question is this system is orthogonal? For orthogonality, the necessity and the sufficient condition from the previous lecture, you know that for orthogonality, orthogonality, the condition is del x del u1. There was a two coordinate system, that's why two very well, but here three coordinates, so we need to three coordinate, that is del y del u1 del y del u2 del y del u3 and del z del u1 del z del u2 del z del u3 must be 0. This is the condition for orthogonality. Now if you derivative with respect to x with u1, you will be get 3 into with respect to this is 1 and this is minus 1 plus with respect to 1, this is 1, this is 2, this is 2 and this is 2, this is minus 1, this is minus 1. What you got? This is minus 3, this is plus 4 and this is minus 4, this is minus 3. This is not equal to 0. So this system curvilinear coordinate system, this curvilinear coordinate system is not orthogonal, right? Now comes into the question B. Find dx square and g for this system. You know d square is nothing but dr vector dot dr vector. Now what is dr vector? So for that you need to know r vector. R vector is I cap x plus j cap y plus k cap z. So I cap x is nothing but 3u1 plus u2 minus u3 and j cap y is nothing but u1 plus 2 u2 plus 2 u3 and k cap 2 u1 minus u2 minus u3. Then what is the value of dr? That is I cap 3 du1 plus du2 minus du3 plus j cap du1 2 du2 plus 2 du3 plus k cap 2 du1 minus du2 minus du3, right? So if you dot with respect to that, you will be get this square, that square and that square. So ds square is nothing but that is the 3 du1 plus du2 minus du3 whole square plus du1 plus 2 du2 plus 2 du3 whole square and this is 2 du1 minus du2 minus du3 whole square. So if you take, this is 9, this is 1, and this is 4, that is 14 du1 square. Similarly, this is 1, 4 and 1, this is 6 du2 square. This is 1, 4, 1, that is also 6 du3 square. And for this is 3 to 6, 6 du1 du2 and minus 6 du1 du3. Just rearrange this, you will get this answer, du3 du2 132, right? So this is the value of ds square. Now you want to find the value of g. G is nothing but g11, g12, g13, g21, g22, g23, g31, g32, g33. Okay, g11, this is g11, this is g122, this is g33, like that. So this is 14, this is 6, this is 6, and this is 6, so this is 3, 3, this is minus 6, this is minus 3, minus this is 8, so this is 4, 4. If you just calculate this, you will be get 100. Okay, you will be get 100. So the value of g will be 100. Now the question, what is the relation between the previous preceding problem? If you already cover up the previous lecture, that is 87, you know the value of this problem was given, the Jacobian was calculated as 10. So here you can see g is 100 and j is 10, so you can see g is nothing but j square. Relation is followed for using from, this is from previous problem, that is problem number 7.78. that is the problem number 7.78. You will get j equals to 10, and here we get g equal to 100, so we can correlate these two equation like that. Clear? If you don't clear, you must comment in the comment box. Next question says that x equal to this, y equal to this, z equals to this, similar. So you need to find out g. So for find g, you need to find the ds square, right? So for that, you can write r vector equals to I cap x, r vector is the position vector, plus j cap y plus k cap z. Put the value of x, that is I cap u1 square plus 2 plus j cap u1 plus u2 plus k cap u3 square minus u1. So what is the value of dr vector? Dr vector is the I cap 2 u1 du1 plus j cap du1 plus du2 plus k cap 2 du3 du3 minus du1, right? So if you dot with r vector, that is ds square equals to dr dot dr dot dr. So you will get, this is 4 u1 square du1 square, this is du1 plus du2 whole square, this is 2 u3 du3 minus du1 whole square. So you will be get this 4 u1 square 5, and this is 4, so this is gives you 4 4 u1 square, this is 1 and this is 1 2, so this is 4 u1 square plus 2 du1 square. Next there is du2 square u3 square, that is 4 u3 square du3 square. Next u1 u2, that is 2 du1 du2, and here that is minus 4 u3 du3 du1, right? So if you find the g, that is g11, G11, G12, G13, G21, G22, G23, G31, G32, G33. Just put the value. So what is G11? That is 4u1 square plus 2. G12 is G22 is 1. G33 is 4u3 square. G12 is 2, so this is 1. This is 1. G13 is minus 4. This is minus 2u3. This is minus 2u3, and this term is 0. So if you expand with respect to any, so if you expand with respect to this is minus 1, so that into that minus that into that, that into that, that is the 4 minus 1, sorry, minus 1, so this so 4u3 square minus 0, and for that this is plus 1, so that into that, that is the 4u3 square into 4u1 square plus 2 minus 4u3 square. So this is 4u3 square, 4u3 square. So if you take 4u3 square is common, so you will get minus 1. Here you get 4u1 square plus 2. Here also minus 1. So you get 16u1 square u3 square. Clear? This is the value of G. Now you need to find out the Jacobian. So Jacobian x, y, z, u1, u2, u3. So this is nothing but del x del u1 del x del u2 del x del u3 del y del u1 del y del u2 del y del u3 and del z del u1 del z del u2 del z del u3. Now put the value. I think you remember the x is nothing but u1 square plus 2, y is u1 plus u2, and z is u3 square minus u1. So calculate this expression. Del x del u1, so this is 2 u1, del x del u2 0, del x del u3 0, and del y del u1 is 1, del y del u2 1, this is 0, and del z del u1 1 minus 1, and this is 0, and 3 will be 2 del u3. So if we expand with respect to this, that is 2 u1, that is 1 to u3 minus 0, so this is 4 u1 u3, right? Now there is says that verify j square equal to g. You can see here g is nothing but root over j, or you can say, so j square is 16 u1 square u3 square, which is nothing but g. So j square equals to g. Here also we got j square equals to g, which is previously also get the same relation. I think clear. So by this video I covered the chapter, curvilinear coordinates chapter already cover. Okay, so this is all about me, and this is my contact details, and this is my YouTube channel details. Go to this channel, you will get the video which already uploaded, and share this video to your friends so that he or she also get benefit from this video. Subscribe this channel if you new in this channel, and those already subscribed, thanks for subscription, and press the bell icon to get the notification of upcoming video. So take care, we'll meet in the next video as soon as possible. Thank you.